Okay, so we were considering the difference in values of importing a certain product when comparing economic and financial analysis. So if we want to find the value on the site for the cost in economic and financial analysis, we should now add, if you want, all costs before reaching the site. Okay, so first we transform to local money value. So we have $28 per ton, and knowing that the shadow rate is 36 local money per dollars. This means that for 1 ton, we have to pay 28 times 36, while in the financial analysis, we have to pay 28 times 30. But the tax is really higher in case of, is really high, while for economic analysis, we don't consider it. So we should add in the financial analysis 30% of the cost. So 30% times 840, so we get 252 local money. Now, concerning the handling charge, for the case of economic value, it's 90% of the financial value, so it's 60 times 90% per ton. While for the transport charge, it's 200 for financial, while 90% of 200 local money for economic. And now to find the total cost of importing a certain product to the site, from the case of society point of view, it will cost 1,242 local money, while from the private owner point of view, it will cost 1,352. So here we can see that the value of the import has less economic value than that of the project owner. So it is from here we can see that it's easier to import from a government side of view than from a certain private owner. Now, what about inflation and relative prices? We know that most countries will experience a varying level of inflation and an increase in the general price level. Sometimes for some countries, inflation can reach 10 to 15% in case we have hyperinflation or we have some periods that are of high risks in the country. Like, and for example, in Lebanon, the inflation is much larger. So it depends on the country if we have stability or not. The existence of inflation raises the question of whether project inputs and outputs should be measured at the prices in force at the time of the appraisal, or at the prices in force when the project input and output occurs. So here, inflation is a critical issue, and it will affect a lot of prices. But what is good is that it will affect all prices in the same way. So we'll have inflation on the costs, and also we'll have inflation on the benefits. This is why when we consider, let's say, a project that can be 10 to 50 years in the future, do we have to forecast inflation that far ahead in order to be able to value our flows of inputs and outputs in a correct way? If we want to answer this question, we can basically say no, because inflation will affect costs and benefits in the same amount. So whenever we do the analysis, its effect will cancel out. So as inflation is an increase in the general price level, we can ignore it for purpose of appraisal. In other words, we are assuming that it affects all costs and benefits in the same way, and therefore will not affect the relative returns. Now, what are the indicators of cost-benefit comparison? Not taking inflation into account doesn't mean that we don't consider the time value of money. There is a difference between inflation and time value of money. And now in the coming slides, we'll discuss what do we mean by the time value of money and how we can take it into consideration. So we have a certain number of methods that are commonly used for comparing costs and benefits of a project, which can be broadly grouped into two main categories. We have methods ignoring the time value of money, and these methods are not accurate, especially if we take long periods. So if we take a project for 1 or 2 years, it's fine if we ignore the time effect. But for renewable energy projects, as we discussed, that will last for a very long time period, we should consider the time effect. Let us first develop techniques ignoring time and then comparing them with other methods that will take time into consideration. Whenever we ignore time, we can talk about a static payback period, while if we consider the time effect, we talk about a dynamic payback period. So first, as we mentioned, we should calculate the static period by considering the time needed to uh, to pay back our investment, as the name indicates. This means that the benefits should be equal to the investment. Okay, so if we consider here the initial investment and the annual net revenues, why we talk about net revenues? Because we always have, let's say, some operational and maintenance costs. So these should be subtracted from the revenues. So the annual net revenues will represent, if you want, benefits minus any cost as maintenance and operational that we should pay, let's say, each year. So maintenance plus operational costs should be subtracted from benefits to constitute the annual net revenues. And we have the investment that is paid at the beginning of the project that should be considered, of course. So we do minus I0 plus summation from year 1 to year TT is the static payback period that we are looking for. So we are looking for the time needed in order to compensate the initial investment we did. Now, if and only if the annual net revenues is equal to annual gross revenues minus annual cost or constant, so we don't have change from year to another, we can use a simple formula to get the number of years needed to pay back our money. Okay, so because if this is constant, you can take it outside of the summation. Okay, and then summation from 1 to t, you can replace it by t. But only if the annual net revenues is constant. If it's variable, I should consider like I can do a table and do for each year what will be the net cash flow until tracking the year where I have 0, and we'll do this together now. We'll do an example on this. But in case it's constant, so we can take A and R in factor, and sum from 1 to t will be equal to t. And then we can say that I0 is equal to the number of years times the annual net revenue. So it's a very simple relation. And then we can get the value of T, which is the investment, the initial investment, over the annual rate of return. But in practice, the majority of projects will not have a constant annual net revenue. It will vary with years. And in this case, we'll develop another method in order to calculate the payback period. Let us take an example. Let us take first an example of a static payback period with a constant rate, but we'll not here in the example. Sometimes we don't take an annual rate. It can be a per day. Yani the rate can be per day, depending on the application that you have. For example, if I considering the following case, we have two lamps, one that is a conventional one, and what is a lamp that is characterized by high energy savings, okay? And we want to compare, if you want, which one is better and what is the time to pay back the cost of it. And of course, the lamp characterized by high energy savings will have a larger price, okay? So let us consider this is lamp 1, which is an energy saving lamp that consumes for 14 watt and costs £2, while a normal lamp of equivalent luminosity of 75 watt costs £0.5. We want to assume that we have 10 hours of lighting per day and a cost of 10 pence per kilowatt hour of electricity consumption, and we want to determine the payback period of this lamp. So as we mentioned before, whenever you compare two alternatives, okay, you need to compare the difference between them. So in order to see what is the difference, we have that lamp 1 is characterized by a lower consumption, okay, because it will need only to a power consumption of 14 watt. This is for lamp 1, while lamp 2 is consuming a much larger amount, which is 75 watt, but also the cost is larger for lamp 1 compared to lamp 2. So we have a difference in cost of 1.5. So here our investment, if you want, whenever we want to compare two projects, we should compare the differences. So the difference in price is the investment I am putting. So I am putting extra 1.5 pound, okay? I need to determine what is the payback period in order to compensate this difference. So I should take into consideration the reduction in the bill, electricity bill. So because of the reduction in power, if I use lamp 1, I will be able, it's true that I should pay 1.5 pound more. So I can consider that my investment I0 is equal to 1.5 when comparing the two approach. Now, concerning my the reduction of electricity bills, this is what I gain. This is my net revenue, okay? Here, we don't have maintenance, we don't have operational cost. So here we are just considering, if you want, the difference in power between the two, because I can save 75 minus 14 watt in power. And since I know the number of hour of operation per day, I can compare what is the amount of watt hour I can save. So if I multiply by the number of hour, which is 10 hours, I can find the amount of watt hour saved. Okay, and of course, this calculation is per day. So I can save per day 610 watt hour. And since the price of kilowatt hour is given, which is 10 pence, equal to 0. So here, this is equivalent to this is equivalent to 0.61 kilowatt hour. We did the conversion because we know the price per kilowatt hour, okay? So now I have the amount of kilowatt hour saved per day. And I know that in monetary term, okay, I multiply 0.61 by 10. So I am saving per day 6.1 pence, which is 1/100 of a pound. Okay, so now in order to determine the number of days which constitutes the payback period, I will divide the investment, the extra investment I put, over the money that I can save per day. So the money that I can save per day is 6.1 over 100 to convert to pound. Okay, so I obtain that I need nearly 25 days in order to pay back the money I paid. And after the 25 days, I will try to save energy. And this is acceptable because the lamp the lifetime is much larger than 25 days. It can last for months, for several months. So this is why I can consider that this lamp is worth of buying. So paying this extra amount will lead to much more energy savings and the cost savings after. So in this analysis, we considered that we have constant amounts. So the cost of per kilowatt hour of electricity will not change. This is reasonable because we are taking an example of comparison over a period less than 1 year. However, whenever we consider energy projects for which the lifetime is more than 20 years, for example, then it's not reasonable at all to neglect the time effect.
Yes.
Yes.
If we have a maintenance cost, how do we account for it?
If we have a maintenance cost, we should subtract it from the revenue. And here, for example, let us say, let us add, for example, per day, we have a maintenance cost, let's say, of 0.01 pence, for example. Okay, so this is the maintenance. In general, we don't give maintenance cost per day. We give it per year, and we'll discuss it after. But just because you asked the question, so I might give you a certain maintenance cost, for example, here per day. Okay, then when you do this analysis, okay, you should subtract from your energy saving, which is 6.1 pence per day. Should subtract 0.01 pence, which is the maintenance cost. Okay, because you should pay a certain amount from this saving, you should pay it for maintenance. Of course, we are assuming here that this lamp is needing maintenance and the other one will not need. If both will need maintenance, okay, you should consider the difference between them. Okay, so let's say, for example, lamp 1 requires as maintenance 0.01 pence per day, while lamp 2 requires, for example, more, requires 0.1 pence per day. So here, this will add to your savings because you will need lower maintenance. Okay, so then you should add, in this case, to 6.1, which are your savings per day, you should add the difference of maintenance, because with lamp 1, you need lower maintenance. So you should add plus 0.09. So if you need a lower maintenance in case of lamp 1, this will add to your savings instead of reducing your savings. Okay?
Yes, clear. And this 6.1 pence is per 10 hours.
Yes, per 10
Right.
hours, but we can say per day because we are operating the lighting 10 hours per day. Because you have a lot of times that you don't need light.
Yes, thank you.
What's your name? Who is
Hilda.
asking? Hilda?
Hilda Hatun.
Okay,
Yes.
Hilda, thank you. Okay. Now, let us consider another example where we don't have a constant, if you want, annual net rate. Okay. For example, we have a certain investment and the investment value is $10,000 that we should pay at the initial time. Okay, and now we are studying for each year what is the annual net rate. So we should do a balance between the revenues and costs. So the costs can include maintenance, can include operational cost, can include labor cost, etc. So we can then for each year do the difference between revenues and costs. So we can get that for the first year we have an annual net revenues of $3,000. For the second year also. For the third, we have more, 3,500. For the fourth year, 3,200, etc. So we can compute for each year what is the annual net rate. Okay. Now, in order to to determine the payback period, first we should add, okay, over years, what is the net annual net revenues. And for example, at year 2, the savings will be 6,000. We are still less than 10,000, so we didn't reach the payback period yet. At this level, the value is 9,500, so we are close, but also we cannot say that the payback period is 3 years. So we can say now that the payback period is between 3 and 4, because after year 4, we have the net revenue will be $12,500. So we started to gain. So now we can say that the payback period is between 3 and 4. And if we want to get it accurately as a fraction, we say the following. We say until year 3, at the end of year 3, we just still have to pay $500. Okay? And since in year 4, the overall savings are 3,200, then if we consider that the gains are equal and it can be divided equally in a homogeneous way over the whole year, then we can say that to cover $500, we need 500 over 3,200 years. So we can get the fraction if you want, needed. Okay, so this will give us 0.156 years. So in total, the number of years needed for payback for the payback of this project is 3.156 years. We can multiply by 12 to have it in number of months. Okay, so this is the general method. We can say that T is equal Y plus A over B. Y represents the number of years before the payback period. In this example, it's Y is equal to 3. Now A over B is A represents the total remaining to be paid. In this example, it's $500. And B represents the total paid back in the entire payback year. So which is here 3,200. So in this way, we can get the static payback period whenever we have variation of the annual net revenue. Now, as we mentioned before, ignoring time is not very accurate, especially when we consider long lifetimes, okay? So the average simple rate of return on investment is the net profit per year as a ratio of initial investment. So if we want to define another factor, if we are still ignoring time, okay? And we want to calculate what we call the rate of return on investment, which is the symbol of it is RRI. What do we mean by RRI? It represents, okay, the annual profit over the initial investment. So sometimes in books we call it sometimes ROI. So rate of return on investment, okay? But in other books, it represents something else, okay? Together in this course, we'll take ROI for us will represent the rate of return on investment, which is the annual profit over the initial investment, okay? And we'll define another terminology for what we call the discount rate that will define anyway, okay? But in other books, you might have ROI as a discount rate. Here we define it as a rate of return on investment, which represent, if you want, the annual profit over the initial investment. This means what is the percentage, if you want, of the annual profit relative to the initial investment. In case we have a constant annual profit, it will be constant for the whole project. If not, we can have a varying rate of return on investment for each year. So for example, if a project makes an annual profit of $2,000 for an investment of $10,000, then we can consider that the rate of return is 20%. So for each year, we are having 20% of rate of return compared to the total value. And sometimes this rate of return, as we mentioned, can vary with years if the annual net revenue is not constant.
And is it related to payback period?
Yes, of course, it is related to the payback period. Larger the rate of return on investment, lower will be the payback period. Okay, because the payback period, if we consider it as constant, if you want, if you consider this rate to be constant, the payback period will be the opposite, because it will be of course, if we consider it as the net profit, okay? So it is the opposite, since you have the inverse, since the payback period is the initial investment over the annual net rate, okay? So here, for example, if you have a rate of return of 20%, this means that your payback period is 1 over 0.2, it's 5 years. Now, as we discussed, sorry,
I have a question.
Yes. Oh, okay.
And this formula works for both the first case that we discussed
Yes.
The one that we don't, that ignore the value of money with time.
Yes.
And the second one, which doesn't ignore.
Yes.
Right?
I am saying that here, look, if you don't ignore the time effect, this will change. I will tell you why, because the annual profit value will not remain the same. Okay, so this formula will not remain as it is, because let's say for each year you have a saving of $2,000. Okay, if you want to take the time into effect, the value of the $2,000 will not remain the same. And for example, take the following example: you have a certain machine that you want to buy. Okay, if you buy it today, let's say the price today is $1,000. Okay, if you wait 5 years to buy the same machine, the price will not be the same. In general, this price will be larger. So for example, after 5 years, the price might be $1,200. This will indicate what?
Yes,
This will indicate that,
inflation.
yes, so the value of your money is changing with time. So to buy the same object, you will need more money after a certain period of time. So you cannot just say, if I want to define it, when I take time into consideration, I cannot consider the following formula. Okay, because the value of my annual profit should be, I should bring it back to zero, because the initial investment I put it at year zero, while the annual profit I am calculating it for each year. Okay, and with time, since this value will be reduced, I should take all costs back to, or all values back to zero, to be able to compare it with the initial investment. Okay, so
Yes.
I cannot just do this calculation, because I should take into consideration time effect. And how we take time effect into consideration, this is what we will discuss in the coming slides. Okay. Okay. So for energy projects that will have a considerable lifetime, we cannot ignore time, of course. So we should take into consideration time's effect. To do this, as we discussed with Hilda, we should consider the net present value. Okay, so we should bring back all revenues and costs to the investment time. This is why we say the method to assess, if you want, the balance of cost and revenues taking time into consideration is the net present value method. And net present value will involve conversion of all benefits and cost streams occurring at different points in time to their present value equivalents, and aggregating them to get the overall worth of the benefits and costs of the project. Okay, so as we mentioned, in order to evaluate the real value of our annual rate, okay, so here you can see, for example, the annual net rate for year one is not only R1 minus C1, we divide it by 1 plus I to the power 1. Now, what is I? I is what we call the discount rate.
The interest.
Yes, the discount rate is a percentage that will tell us, if you want, what is the degree of our confidence in future. So if I consider that I have $100 now, if I am very confident about the future, okay, then my discount rate is zero. This means that I don't have any variation of the value of my money, which is not reasonable in general, because with time, the value of my money will be smaller. Okay, but if I want to be very optimistic, I can consider that the value of money will remain the same. And in this case, I can ignore time. So if I ignore time, this means that I is equal to zero, and I will use the previous analysis. But now, because we want to consider time, we can consider a certain range of discount rates. And how to decide on the value of the discount rate, this is really challenging and will require the study of the economy of a country for a long period of time. So we cannot decide on the discount rate by just doing the analysis for 2-3 years. So we do economical analysis back to 50 years maybe, okay, or more. So whenever we want to decide on I, let's say, we can observe how the value of money is changing with time. In stable countries, the discount rate can be relatively small because of the stability. So, you know, a lot of factors will affect the discount rate: political factor, economical factor, social factors. So all of these should be implemented whenever we want to do the analysis to be able to decide on I. In general, percentages between 0 and 5% are given for stable countries, okay, that are characterized by solid economy. While whenever we go to developed countries or whenever we have risks, this discount rate can be increased. And it can, of course, in general, if it's very large, no one will invest, because you have a high risk. And if you do your analysis, this will increase your payback period. So larger is I, larger will be your payback period, lower will be your benefits. So you should pay attention. Okay. Sometimes, why sometimes we can go to developed countries instead of implementing our project on developed countries? Who can tell me? Can you give me an example of project? Yes.
Could you repeat the question, please?
Yes, Karim. I'm saying that if I have, let's say, a certain project, in general, developed countries are more economically stable. So why can I think of investing in developing countries if I have more stability in developed ones?
أكيد it's better to invest in a developed country لأنه it's very risky if you will invest in a country مثل لبنان.
Okay.
إنه راحة العملة.
Okay.
Imagine you built a house وبدك تبيع باللبناني, so راح يصير في a big problem.
Okay, but on the other hand, you have a lot of investors that will invest in developing countries. Why? Because it depends if you want on the type of business that you are doing. Okay, let's say if you have a business that is completely automated and just relying on machines, then of course you will invest in developed countries where you have stability. Okay. On the other hand, if you have an industry where you have a lot of operational costs, you need a lot of employers, then you can think about going to developing countries where the employers, if you want, rate is much smaller, and you should pay them amounts much smaller than paying, let's say, in Europe or in US. So in such cases, you can go to developing countries. So all depends on the type of business and what is the operational cost that you have. If you have, okay, so all of these issues will affect your selection. So from one side, it's true that in developing countries we have small discount rates, we are more confident in future, but also operational costs are much smaller in developing countries. So this is why I can do the comparison, and based on this I can decide. Okay. In general, whenever we want to decide, we don't take one value of the discount rate. We study a range of possible discount rates. So because when I have a project in mind, I have several possibilities where I can invest in. I can invest in USA, in Europe, in let's say in Arabian countries, etc., in China. And you know that because of this issue, a lot of investments were done in China, because it's true that it was not developed as other countries, as US, but the operational cost was really smaller. And this is why we had a high development of industry in China and India, etc. So if we go back to our formula, so we can consider that for each year, okay, for each year, the value of my money is decreasing. This is why, for example, for year one, when I do the balance between revenue and cost, R1 minus C1, I should say, when I say the discount rate is, for example, 2%, this means that each year I will lose 2% of the value of my money. Okay, so I should divide, in order to get back this value to present, I should divide R1 minus C1 by 1 plus I. I is the percentage. So here, if I take 2%, it's 0.02, for example. Okay. And each year I should do this. So now if I take year 2, I should divide again by 1.02. So I should multiply this. So now I will do R2 minus C2. But now instead of just dividing one time by 1.02, I should divide by 1.02 times 1.02, because I'm going 2 years backward in order to go back to the present value. Okay, so I divide then by 1 plus I to the power 2. And I will do this so I can put a general formula, because each year I'm dividing by 1 plus I. So the overall formula is the following. The net present value for a certain period of time is summation from year 1 to the years that I am considering, times for each year I do the revenue minus the cost, over 1 plus I to the power t, to bring this net revenue and cost back to present, minus I0. And in this way, I can obtain the net present value. And then once I obtain the net present value, I can consider that I paid back my project when the net present value is equal to 0. So the year for which the net present value will be equal to 0 is for me the payback period. Okay. Now, of course, it's not enough to assess the payback period. The payback period is one of the important indicators, because lower the payback period, better the project is. But we have other factors that we'll discuss in a while. So we have also, if you want, the net profit at the end of lifetime. So I want to know at the end of lifetime of my project, what will be the net present value of that I will gain. Okay, and this gain should not be just, let's say, if I gain, for example, $1,000 for an investment of $100,000, it's not acceptable. While if I gain $1,000 for an investment of $2,000, it's great. Okay, so this is why we'll see that we can define in other factors that will help us into assessing the economical viability of our project. The first criteria, if you want, that can be an indication.
Professor.
Yes.
In some projects ما بيكون في payback period.
What do you mean by this? يعني we are not able to pay back our investment?
لا يعني مثلا بال government project
Yes.
ما بيكونوا معمولين ليربحوا منهم.
Okay, it's
مثلا
true.
مثل الرودز مظبوط. ما
مظبوط.
بيكون في payback period.
إيه. بس حتى انت كريم، ما انت وقت بدك تعمل a certain investment، اوكي مظبوط، يمكن ما تربح، بس you will compare. يعني انت الجوفرمنت بده يجي يعمل project انه هو ما حيربح let's say، بس تينقي which if you want which project to go through، حيدرس several alternatives، صح؟ يعني هو
بيروح على ارخص project،
حينقي ارخص شيء. so حتى لو مثل ما عم تقول انه ما كان يعني ما كان هدفه يربح، at least he will try to put the lower cost as much as possible، صح؟
yes.
حتى sometimes في countries بتيساعدوا انه to simplify the work and to go through a project، بيجبروا for a certain time period انه any person that will use the road to pay money. And in Europe, for example, if you take some roads, you should pay money. So this is to help